First question would be like, how are you having fun at TechDays? And I think you are, because you're still around and it's almost the end, right? Friday afternoon, one of the last sessions before we close down, and you're in this room listening to me talking about building secure ASP Core MVC applications. So thanks for that. So what are we going to talk about? This is the topic. First, let me briefly introduce myself. You always need to click your clicker before you start, right? Hold on. Has to do with focus, probably. Yes. So who am I? I'm Niels Tanis. I work as a security researcher for Veracode, and I've got a background in .NET development and in security consultancy and pen testing. So in my daily job, I combine those worlds together and try to figure out, like, hey, how easy can somebody make mistakes when developing a .NET application? That all comes together for our service. We offer static analysis of code bases, and that's the thing what I'm doing during my day work. So if you want to talk about it, come see me afterwards. But that's not today's topic. I think if you talk about building secure applications in general, we can state that it's a tough job to do it right. Especially if you're doing it on top of a new framework that's like rewritten from scratch. How do you know as a developer that you're doing the right thing and that you're not unintentionally are making mistakes? Same counts for like how good are the APIs helping you out and guiding you through taking the right decisions. Or is a mistake easily made, right? That can also be the situation. So that's in a nutshell what we're going to cover today based on the following agenda. I'm going to give you a short introduction of .NET Core, MVC Core, and so on, just to have the full story available. Then we're going to move to an application, which we're going to see how we can process data, of course in the wrong way, how we can then of course present data, right? A web application will take data from an end user or from any external source, will do something with it, and will then give the result back to the requester. So that's usually the root of a lot of problems. Then we're going to see how easy it is or how difficult it is to adapt ASP.NET Core for some newly introduced web standards. And then at the end, we also want to make sure that we are analyzing our current solutions for the flaws that we've just discussed, right? So I would just like to show you some ways on how you can determine and how you can analyze your current solutions for the problems. Then there will be a conclusion, and at the end there's a possibility for question and answer. So .NET Core, ASP.NET Core MVC, I'm probably not going to tell you something new because this is a Microsoft conference, but it's been around since last year, June 2016. And one was released in December or November of last year, and recently, I think it was August 2.0 was released, right? So in a really quick pace, Microsoft has released ASP.NET Core and MVC combined. The nice thing is it's open source, it's modular based, right? So it's not a full framework you need to install on your machine. It will just compose the application that you're deploying on a machine based on modules that will be get from a source. And based on that, it will run on every platform, right? It's Windows, Linux, Mac OS X. If you ask Microsoft, I'm doing microservices, what I'm going to use for it, they will say .NET Core. ASP.NET Core itself is a rewrite from MVC from the full framework, and it runs on both Core and the full framework. A pattern, probably also familiar, right? The model view controller. In this case, model represents the data that the application processes. The view will present it, will push it back to the requester. And the controller contains all the logic and will have the initial request, and it will act on requests that are done to the application itself. So we're mainly going to focus on the controller part. That's of course where all the magic happens. If you create a .NET Core 1.1 application, you will get this program. You will see it's probably not new. It's a web host builder. It will hook up everything for you. There's one class, which is the startup. It contains a lot of things that you can configure. We're going to talk about that one today because there's a lot of stuff we can fiddle around with. And then, of course, the run will execute it. So I'm using some code snippets. You will find that in a project on my GitHub account that contains all the examples I'm talking about. It also contains the analyzing part I'm going to talk about later on. And I'm going to make some comparison between the MVC and MVC Core. It's not a strict, let's say, I'm going to give you a list, and these are the differences. No, I will point out what the differences are. And because the research was based on 1.1, I haven't fully done 2.0 yet, but I will point out if there's something significantly different you need to be aware of. So with that said, we've got an application running, right? Let's take a look at this pretty simple first code snippet. And what we see over here looks like a default controller, has just got one index method that will return a string. And that will give the type back in a nice hello from type. So if you see this, just what will be the first thing that pops into your mind if you're seeing this, right? So there's nothing fancy happening, there's no input. It will just reflect a string back to the requester. But is this really a controller that's being exposed? With MVC Core, it is, right? Because MVC Core will take convention-based the name controller, and it will try to resolve controllers that are available within your application. And it will do it even with every assembly that's used by your application. Meaning that if you're, let's say, pulling in a third-party library, and I think a lot of people are doing that because based on NuGet we will compose our application, you will pull in, let's say, Newtonsoft, and if there is a class that ends with controller, that will be exposed. And we trust the third-party library to do the best job they can, right? Those are usually people that are doing open source work, which is pretty awesome, right? They help us out being more productive. But it's good to be aware of the fact that those classes, if there is a class that is contained, and it may be done intendedly or unintendedly, right? We know that software has been compromised, libraries have been compromised for the main purpose of hijacking as much computers as possible. You can probably imagine what will happen if Newtonsoft gets injected. And there's a small controller which nobody will notice, but it's in and everybody uses it. It will have a lot of impact, I think. So it's important to be aware of the fact that controllers are found across your application. And this is not different for MVC, right? MVC has got a controller factory that will find controllers which inherit from iController. And with MVC Core, it will only look at the convention based of the name of controller. Can we do something about it? We surely can. So within config your services, there's something called an application parts manager, and that will help out the application on resolving the different types that are used by the MVC pipeline. That means that there are controllers, there can be a few components, there can be tech helpers, those are all found. And we can limit the assemblies that the application parts manager use in order to resolve controllers. And this is an example which is derived from an example that Microsoft has given. It will search for, in my case, it will search for namespaces. It will see the current assembly namespace. It will use that one. And it will say controllers need to come from this assembly only, or from everything that starts with Microsoft.ASP.NET Core as a namespace. Still namespace, somebody else can still use that namespace, right? There's nothing limiting in that. Within my code examples, I've got a controller feature provider, which is one of the internals that the application parts manager use to resolve controllers, which I will show how you can then map types based on the assembly, which is more strict, right? So there are different ways, and I think it's at least good to consider that you want to limit the controllers that are exposed, because more controllers in your application means a larger attack surface, and more people can maybe do bad things, right? So application parts manager has done its job, has found controllers in your application, and it exposes it, right? We need to get a request mapped to that controller, right? And that's what MVC routing does for us. So similar with MVC in the full framework. With ASP.NET Core MVC, you will get a default route which looks like this. And just to illustrate a bit, we have some examples, URLs underneath this, and you will see that there's an info controller with an edit operation, right? So that will be info controller that contains the action edit. It will have a query string parameter of type of name input with data inside of it. And the second one is different. It will have the info controller, it will have action delete, and it will have a route parameter with value of 2, right? So there's a distinction between where the data is being fetched from. Aside from the routing, once a request is being processed, there's also something called model binding, right? Model binding will make sure that the controller gets the data it needs based on the request. It will just search for in different locations. It will start searching with the form inputs. Then it will take a look at the route parameters, and at the end it will take a look at the query string. And in that order, it will populate the data that's needed for the request. So if you've got a controller that accepts a complex object, then that thing will be mapped internally, right? So based on the model binding. So those two concepts, routing and model binding, will end up having something executed. So let's move back to the code. We know those two concepts. So this is an orders controller, which in this case derives from controller, which is the base of ASP.NET Core. It's also available, got some methods that will help you out. We inject a data context, which is an ordinary entity framework core data context in a constructor, right? DI is part of ASP.NET Core, you can use it. And what we are doing then is, you see over here, is a create new method on a controller, which accepts order, and order is a class that can be stored by the entity framework context. We will then save the changes, and then afterwards we will redirect back to the index, right? So, seeing this method, there is something wrong with it, of course, otherwise I wouldn't show it, and it looks pretty simple. It's a simple example. Would this method accept an HTTP post request? The answer will be yes, of course, right? It will accept that. Will it accept an HTTP GET request? Yes, it will also do that. So, an HTTP GET request should never change the internal state of an application, because that's the root of a lot of problems. If you have, let's say, a request forgery issue and it can be achieved by a simple GET URL, then you can probably imagine what happens, right? So we at least first need to make sure that we limit this based on HTTP post and say, okay, this is the only verb that we're allowed. Or if you're doing API, maybe you want to do a different route. But let's say this is a form that's rendered back and we want to do a post back to the server. I already briefly touched what's next, right? So what's the other issue that's still with this? We can post data, and somebody from an external page can also create a form and still post the data, right? Which is the request forgery attack. So we need to at least make sure that we do a validate forgery token on that method. And make sure that that is a synchronizer pattern, which is a token that's inside your cookie and inside your form. Those two need to match in order to get this data or this action executed, right? In order to store that data. So, it's getting better, right? If you're doing a new controller inside of Visual Studio and you do the default scaffolding, this will all be done by default, right? You will see the attributes. You will say, like, this is the object I'm going to expose with this controller, with this API controller maybe, and that will all be done, right? So just want to illustrate that, of course, code can be written differently, but we need to make sure that this is in. What else is wrong with this? What's missing? Data gets into the application. The order object will be mapped by the model binding we talked about earlier. Should we maybe not validate the data before we process it, right? That's the next step. So within the default controller, there's something called model state, or at least with that context, there's something called model state that we can query for if there are any errors during the model binding, and secondly, if there is any data validation error. So we want to make sure that we validate the data in the best way possible. And if we then zoom in into the order class, you will see, like, hey, this is the data structure, and there are a couple of data annotations that are done. And those need to be validated, right? That's first step. Every application first needs to do input validation before it processes its data. Right, so the data annotations right now are in the entity framework model that's called order, which you see over here. So getting one step back, if we see this method, and we saw the structure I just showed you in the next slide, what can be another issue with this method? And focus on the fact that there's an order object, and I'm just going to tell it to you, of course. The order object contains a lot more data, right? And there's something possible in this case, which is called mass assignment or overposting of data elements. So what we want to do is we want to limit the data that can be submitted throughout this order object, right? And this is definitely not the best solution to do this, but the bind attribute with MVC core, the nice thing is that it only has a whitelist of attributes that you can define. So you need to explicitly say, like, these are the fields that I expect to be processed in this way. I think that's good. Compared to MVC in the full framework that has got a white and blacklist, and blacklists are usually not a good starting point. So seeing this, right, this is at least from what it was and what it is right now in a better shape, right? We do input validation, we make sure that we limit the way that this request can be used, and we make sure that we limit the data that gets accepted. A small sidestep within, and this is a slide that contains a lot of code, but I'm going to talk you through. There's another overposting issue within MVC core if you're using the default controller that's inside the framework. So there is a generic method that will allow you to do a try update model, which you see in the line of the if statement in this slide. So pay attention to the fact that the controller method in this case only accepts an ID, which is even optional, And then at that point, it will get the record from the context, right, from the data context, and it will match it. And then the try update model async will match the model binding data to that object which has just been fetched from the database, meaning we've got the same issue as we saw earlier. This is also a mass assignment or overpost issue, because it will just happily map every data element it gets, and it will fetch it from from the different locations. So a small sidestep, I would not use this method, but I will get to that later on, once we conclude. So you should, at least, if there is a need for you to use this, there is an overload that contains a predicate that will allow you to define the properties that you want to accept. In the same way you've got the string in the bind attribute, this predicate will say, I would like to have property X being passed on through this way. So there's a way of fixing it. So wrapping up, processing data. As I mentioned, HTTP GET should never change the internal state of the application. That's rule 1. We need to make sure that we protect our methods for request forgeries, right, by applying the validate forgery token attribute. And the nice thing with MVC Core is that there is an auto-validate forgery token filter that you can push into the pipeline, which does it by default. And it will do it by default on every HTTP method except, I believe, get, head, trace, and options. Those are excluded, but the others all need to supply the token. And if it's on the controller method, then that will be enforced. The nice thing is that Core 2 has got some tech helpers that will allow you to compose the form, and that will include the token by default also, so you're pretty good. Unfortunately, the validate forgery token filter is not put on by default. It would have been a nice thing if that with Core 2, that it would have been put on by default in a template once you create a new project, right, for example. Doesn't mean that you cannot do it yourself for your organization. If you know that you're going to use this in this way, why not put that filter in your template by default, and then make sure that within the configure services of the startup, the auto-validate forgery token attribute, which is a pretty long word, if you try to say it quick, needs to be pushed in by default, and this will help you out. If we then move back to the processing of the data, explicit validation of your data, of your model is of course important. Make sure that you use data annotations and that you also check the model state is valid, right? It's all pretty straightforward. Be explicit on where you expect the model binder to fetch the data fields from, right? There are different ways of annotating it. Do you want to expose an entity framework data object throughout the controller? I would say no, you would use specific view models that you annotate with data annotations, and that you can also annotate with the model binding where you would expect data to come from. I think that's pretty obvious. There's no need for ambiguity where data comes from, because there might be something going wrong and then somebody can misuse that, right? If there still is a need to expose more complex object types, make sure that you bind with the attribute, or if you're using the try update model async version, make sure that you put in the predicate that will limit the data that gets accepted. So, we talked about processing of data, and now let's move to the other side of the presenting of data. And now I'm going to see if you're still with me. This is a controller class, and who thinks there is something wrong with this controller class? Yeah, you can raise hands if you want. Of course there is. Technically, yes, there's a problem, right? This is a typical reflective cross-site scripting, accepting input from external and reflecting it back. But with MVC Core, if you have it configured default, this is not an issue, because string types will be returned as text plain content type, compared to what MVC does itself. MVC will have text HTML if you return a string by default, and then you've got reflective cross-site scripting. Of course, your browser will complain about it, but still, this is not a good thing. So, if this is in MVC Core, and if it's configured in a default way, this is at least, yes, there's a cross-site scripting issue, but it will be, you cannot use it because it's text plain. If you want to have it return text HTML, you need to explicitly annotate it with produces. And that can be done on top of the method or on top of the class itself, right? So that should be a flag. If you're doing a code review and if people are doing this, then you should look at the internals, because there might be something. If there's data not properly sanitized, then yeah, we need to make sure that we do the right thing, right? There is both MVC and MVC Core, there's a class called content result. In this case, MVC Core, this is not vulnerable. With MVC it is. because the content type in the same manner is set to text plain for MVC core, and for the full framework version this is text HTML. If you want to have this one, you need to explicitly define the content type, like, hey, I'm returning text HTML, so that's the content type. So how can we fix this, right? Let's say we still need to do that, and we still need to have the controller method return HTML in a string, which is of course a bit weird of doing that in that way. What can we then do in order to remediate the cross-site scripting flaw, right? So in this case, we're not doing input validation, but we're using the HTML encoder. And the nice thing about MVC core is that it's got its own HTML, URL, and JavaScript encoder inside of the DI container, which is the derivation from anti-cross-site scripting. So it uses a set of characters that you're allowed to use. These are good encoders. Those are used by all the components of MVC core, and you can also configure it a slightly bit different, right? Because it's pretty strict. If you're using, let's say, a Russian or a Chinese character set, those characters will also be encoded. And maybe for some reason you don't want to do that, then you can soften it a bit by saying, okay, I don't want to encode this code pages, and it will help you out. There's a lot of good documentation on the Microsoft doc site about this and how you can fix this. But the basis is pretty good, and it's nice that it's inside, and it's also good that it's part of the DI container, so it still allows you to configure it maybe differently or replace it, and there's a lot of control. So in this case, we encode this, and then we have remediated the cross-site scripting, right? A good thing. So, but why would we use a controller to present the data if we've got razor views? This is just a piece of a page. Which you see that there is a model being defined that contains a list of orders, enumerable of orders, and internally it will loop over the orders and it will render a table row. Pretty straightforward. This is almost equivalent of what MVCC in the full framework does, right? There is a default HTML encoding done, in this case by the DI HTML encoder that's inside of your pipeline. If you call the HTML raw helper, it will wrap that string inside of an HTML string, and that HTML string is an indication for Razor not to re-encode that piece of data again, because it says it's already encoded, I don't need to touch this one. So that's the one you need to pay attention to. If somebody's using that, or based on the HTML raw call, or based on, let's say, a view model has got an HTML string property inside of it, then you should do a review and make sure that the right things are done, that the input is validated, and that the output is still properly encoded. In this case, we see persistent cross-site scripting. If the data comes from a database, it's displayed, somebody has got the ability to type in the description, post that data, it will be returned back. We also see some, aside from HTML helpers, some tech helpers. So tech helpers internally all use the encoders, and they all do a pretty good job, so don't need to worry about that. So based on presenting data, of course, it's important to make sure that we perform input validation in our application, and that we perform context-specific output encoding, meaning that if we're rendering back a piece of HTML data, we need to HTML encode it. If we're creating a URL that contains a value that we want to, let's say, concatenate in that URL, then we need to use URL encoding. And the default encoders are inside of the ASP.NET Core MVC pipeline, and those are pretty good. The tech helpers also do a good job, and we need to keep an eye on HTML raw, the raw helper that will wrap a string inside of an HTML string, and also the use of HTML string itself. So, with that said, we talked about the way how MVC works, how it routes requests, how it binds the model, how it can process data, and how it can return data, right? So that's all pretty much covered. Let's now move to extending MVC core, and then maybe have some new web standards included in the application itself. So the standard I want to touch in this particular case is something called same-site cookies. I'm not sure who is aware or who is known of what same-site cookies are. Raise hands. I'm sorry, I didn't give you the second sentence. Same-site cookies. Okay, cool. I'm going to explain it. So same-site cookie is an additional flag you can put on a cookie that will instruct the browser to limit the use of that cookie in particular situations. There are two policies defined. The one is called lax and strict. And if a cookie value has got a same site set to strict, which looks equivalent, let's say, like if you've got an HTTP only flag on your cookie, it's just a string literal that will be added, right, into that cookie value. If it's set to strict, then the browser will deal with it in a way that it was third-party cookies disabled in your browser. Meaning that if you log on to Facebook and you've got a session cookie which is set to strict, then you're going to look at Facebook, then you're going to move to a new site. Then you're going to move out of the Facebook domain. Let's say that at some point you get redirected back from the new site to Facebook. Same site, cookie will then enforce that the cookie is not resubmitted, meaning that if you get back from the new site to your Facebook browser, then the session is invalidated. You need to re-log on, right? So Lex does almost the same. Like with strict, it's completely prohibited to use it. It won't be done by the browser. With Lex, it's a little bit more subtle. It will still allow top-level navigation. So let's say if you're moving from Facebook to a new site and there's a link that you click on, that will be a top-level navigation that will change the URL of the browser. Then the Lex cookie will still be submitted. That value will be allowed by the browser to push through. So then it's more convenient. It won't break the sequence of a user getting back to Facebook because it's annoying if somebody needs to re-log on, right? So those two concepts can help out, deal and mitigate a lot of our security issues, and the browser can help out with doing that. I think that's pretty cool. Let's say with request forgery, we have taken care of all the stuff that I've showed you earlier, right? So we have put in the tokens, we limit HTTP post. Let's say for some reason an attacker has got the ability to determine the cookie values or the token values of your request forgery token, which needs to be unique, right? Maybe for some reason he's got a hold of something that's valid. And let's say he then introduces, he creates a form and then allows all the data to be in. It's an HTTP post. It's cross-domain, that's allowed, right? He puts in that token and all the other data, and then he forces the user to maybe visit that page or submit it when he visits it in that way. If there's no same site, then the request forgery cookie will also be submitted. If same site strict is applied on that cookie, it will be cut off, right? So even though the attacker has got a hold of the value of the token, it can still not be successful in doing the request forgery, which is pretty good, I think. Another side channel, that's the second thing I'm going to talk about. Another cool thing is that last year there was a researcher from the KU Leuven, which is called Tom van Gutem, and he did some research on resource leakage and how it can be used as a side channel. Imagine that you're on Facebook, and let's say at some point, or if you're downloading your image profile picture, that's a bigger size, right? Because you have uploaded your own picture. That's usually some nice picture of you standing somewhere, or maybe a picture of your kids, right? You will share that one, but that size is distinctive from somebody who is not logged on to Facebook or maybe even doesn't have an account, right? If somebody requests that profile picture, then the size will be different. And he shows, I believe, 5 different ways of how you can instrument the browser on determining if the size is different compared to one and the other. And which is pretty powerful because it can be used to determine what your interests are, like what groups are you part of. He showed, let's say somebody has got a hidden Twitter profile, he can show all your followers because you can just find enough information based on doing requests on the resources. And the fact that the browser exposes sites, like you can cache an object from any arbitrary site inside your own page. That's possible. Browser caching will accept it. It's pretty cool what you have shown. But if same site was applied on that cookie, then that won't be successful. If somebody puts an image tag on another page that loads your profile picture of Facebook, then that won't be successful because the browser will cut it off. So pretty powerful. It will help mitigate a lot of problems, right? This is not the real solution, but the browser can help out creating an extra layer which limits the risk, and that's cool. So how can we fix MVC Core 1X in order to do this? So in my demo project, I created a same-site cookie manager, and in this case, in this example, I'm overriding the cookie authentication options. So that's the internals of that piece, and that will write out the cookie if you've got a successful logon, and you will get a form cookie pushed back to you. It was pretty tough because I needed to rewrite the whole thing, but the nice thing is that it can be replaced because of the whole DI graph you can still influence once the MVC core app is created, right? So it's It allows you to replace it, that's pretty cool, but it was some work, and this only took care of the session cookie. And I also would like to have the request forgery cookie covered in the same way, right? Lax needs to be on the session because that's convenient, and strict needs to be applied on the request forgeries. Luckily, with MVC Core 2.0, the cookie middleware was being introduced, and they've rewritten the whole way that cookies are being managed and being written out to the client. And the nice thing is that this middleware already is aware of same site. And the good thing is that it also flags the cookies in the same way I just described to you. So session cookie will have a default of lax, and your request forgery will have a default of strict. And that's cool. That covers a lot of things. Even if your tokens are exposed, you still have the browser that, in this case, helps you out instead of doing the opposite, right? So it turns out that it's now, and that this is a nice example of the quick pace that ASP.NET Core is releasing, and the ability for them to quickly adapt this and include this. I think this is pretty awesome. So we talked about processing of data, presenting of data. We have introduced some new web standards. Now let's move on to if we want to analyze the current solutions. So Microsoft has rewritten the whole compiler infrastructure with Project Roslyn, which you probably are aware of, but that will allow you to have more insights of the internals. It will allow you to do stuff with syntax trees, with semantic models. There's a lot of stuff inside. And one element is, of course, code analysis, which allows you to create a code analyzer that you can even use in Visual Studio. Nice thing is that it's like the developer immediately sees if he's doing something wrong, so pretty powerful. If you want to have more insights on this, then I would suggest that you move out to the auditorium directly after my session, because Bart Smith will do a talk on analyzers and creating these for Visual Studio, I believe, or at least create some Roslyn analyzers. Aside from an analyzer, you can also create a standalone app. So there's in the Roslyn SDK template, you have got the ability to create a standalone scanner. And the one downside with MVC Core being released in such a quick pace is that usually you can, if you have a normal .NET project, you can just open up the solution with Roslyn by saying, I've got a workspace, and load this solution. It will see all the projects, and it will load everything. It will allow you to compile. And the nice thing is that you will have a syntax tree of a file, right? A C# file parsed to a tree that you can traverse. But there's also semantic information about which types are eventually used. And those two are pretty, if you can combine those two, you can ask pretty direct questions, and that's good. So with ASP.NET Core and the web project that's in right now, that's not parsed by Roslyn by default if you have a workspace and if you load it. And that's a pity. Maybe I should create it, I don't know. Maybe I should contribute to that. That might be a good idea. But we can still take syntax trees and parse it in that way. And that's exactly the analyzer I've written in the current project. So let me walk you through briefly what it does, because it's a lot of code. So just assume that the tree in this case contains a controller class, like a C# file that's being parsed to a syntax tree. And we can just then say, okay, give me every public method on this controller, right? Because we know public methods are exposed. And then for each method, we loop over it, and we can say, like, okay, consolidate the attribute list of this method and see if there's an HTTP post in. If it's in, make sure that validate forgery token attribute is also set. If not, ring a bell, or at least make a report that it's not done in that method. Even better situation will be if you've got the filter turned on by default and somebody needs to explicitly put the ignore validate forgery token attribute in, right? That's the opposite. That should also ring an alarm bell, because somebody does it, and that's probably done for a reason, so you maybe need to revisit what exactly is happening at that point. So that's a simple check, and it's a simple tool, and it's just doing some basic checks. It might, and I think it's pretty powerful, right? So I'm not saying that, because I work for a security company, there's a whole lot of stuff you need to do when you're developing your software, right? You need to do threat modeling at the beginning. You need to scan your application with maybe some static analysis that takes a look at the whole application. But these are small tools that will help you out quickly pinpointing stuff, right? In the same way that you can also create your own templates pretty easily and just use them. Why not? It's there. So yeah, use it. And the last example I'm giving over here is checking if there is a model state is valid call inside of that syntax tree, right? It doesn't say much, but at least if a developer has introduced it in this method, he probably thought about it. Maybe still need to review if it's covering everything, but I think it's pretty cool. So that gives you the ability to scan your solutions based on the stuff that we have just described. So, wrapping up and concluding what we have talked about today. So I think it's important to be aware in general of your application and what your attack surface is, right? The controllers example I gave at the beginning is also applicable to MVC. And as soon as a controller is exposed, it's an attack surface for somebody to look at, right? So be aware of that and make sure that you do proper input validation and output encoding for your application in order to reduce, of course, logical flaws, but also cross-site scripting, the output encoding. I think compared to MVC, the defaults of MVC core are pretty good because you really need to do an explicit change in order to be vulnerable, right? There's things that I've shown about the content types being set. You need to set it explicitly to text HTML, which will then result in the reflective cross-site scripting we have seen. So that's cool. Still, keep in mind that you can rearrange the whole pipeline of MVC. You can put out some of the encoders and say the default encoder in my case will be text HTML, or the default content type of my app will be text HTML. But the default that you get from the templates are good, so that's nice. The APIs give good guidance and explicit changes to be unsafe. One good example is that for .NET Core 2.0, running on different platforms, Windows needs a different implementation for than Mac OS X. And with Mac OS X, usually if we do, let's say, SSL validation, you need to, maybe for development or maybe for some other reason, suppress any errors occurring, right? You do that based on setting the handler to don't validate this certificate. For Mac OS X, you cannot use that interception, and there's an unsecured default for that. And there's a delegate being introduced in Core 2.0, and if you search for it, or if you ask me later to share it with you, I will search for the exact name, but it has got an explicit name that will say, like, if you do this, you're doing a dangerous thing. And I think that's good. That's also an example of APIs that are explicit, pointing you out to doing the wrong thing. And the quick release cycle of ASP.NET Core, it is a shame that, let's say, the tooling maybe is a little bit lacking, right? So with 1.1, I believe the tooling with Visual Studio got a bit more stable. You can do some project with 1.0. It was not that good in my opinion. But then it allows still to have a lot of innovation, as we saw with the same site thing, and it is implemented, right? Same site is unfortunately only supported by Safari and Chrome, I believe, but it's good that those standards are being adapted and those are part of the defaults that you use. So this is my conclusion. I'm going to end up with questions, if there are any questions, or if it remains silent. So you can always, of course, email me or reach out to me on Twitter. The GitHub account contains the template, or at least contains the project that I've used for the code snippets inside my template or inside my presentation. And it will also have the Analyse that you can use yourself. And if you want to know more about Roslyn analyzers in Visual Studio, then get out of your seat and run to the auditorium, because I believe that Bart will start in 5 minutes. So that's it. Thank you.